Hello everyone and welcome back to Instrumentation Hub. In today's video, we are going to learn about operational amplifier, which is nothing but the OPAMP. OPAMP is the one of the important components or important part of the electronics along with all others. So friends, in today's video, learn more about OPAMP. So without wasting any time, let's get started. So friends, as you all know that electronic field has many branches and each branch has its own application. As I said, electronics has many branches. So what are those branches? So the various branches of electronics are industrial electronics, instrumentation, communication. Communication is also known as the electronics and telecommunication, and power electronics. And friends, various electronic circuits used in the application of these branches, and those applications are like amplifiers, waveform generators, timers, arithmetic circuits like adder, subtractor, multiplier, and many more. And you know the one amazing thing, one electronic device which is used to construct all these circuits is operational amplifier or the OPAMP. And this is the importance of the OPAMP in the field of electronics. As I mentioned, there are so many applications of OPAMP in electronic field. I will tell you some of those. So, some of the important applications of OPAMP are amplifier, active filters, arithmetic circuits, voltage compensator, log and anti-log amplifiers. Apart from this, there are many more like timers, rectifiers, multivibrators, waveform generator, regulated power supply. So, the single component, which is OPAMP, is used to construct all these circuits. So from this you can understand how important OPAMP is in field of electronics. And in today's video, we are going to learn many things about OPAMP, like how it looks, how it works, how many terminals it has, etc. etc. So with this note, let's move to the second part. Now let's understand why it is called as an operational amplifier. An amplifier which could be connected in various configurations to perform a variety of operations such as amplification, addition, subtraction, differentiation, integration. Hence, the name is operational amplifier. During the initial days, the OPAMP were being extensively used in the analog computers. OPAMP is basically a multi-stage amplifier which uses a number of amplifier stages which is interconnected each other to complicated circuit. These internal amplifiers use a transistor or FETs as an amplifying device. Initially there was the conventional amplifier, but the OPAMP, operational amplifier, has many advantages over these conventional amplifiers. Like it has smaller size, its reliability is higher than the conventional amplifiers, reduced cost as compared to the discrete circuits which is used before. Also it has a low power consumption, it can be easily replaceable, and some OPAMPs can be used in different applications too. Okay, now let's move to the another part, how the amplifier looks like. First we will see the circuit symbol for OPAMP. Okay, so on your screen now you can see the circuit symbol for OPAMP with its different terminals. And OPAMP has two input terminals and one output terminals. The two input terminals are the inverting terminal and another is a non-inverting input terminal. The OPAMP performs or it takes the action according to the input provided to these terminals. As per the input, it will give the desired output. Also, the OPAMP has two additional terminals, which are two supply voltage terminals. The above terminal is plus VCC, which is used to provide the positive supply voltage to an OPAMP, and the another one is VAE, which provides the negative supply voltage to an OPAMP. Okay, now move to the other part. What will be the input, and according to the input, what will be the output of OPAMP? Let's understand by terminal. The input terminal marked with the negative sign is called as an inverting terminal. If we connect the input signal to this terminal, then the amplified output signal is 180 degree out of the phase with respect to the input. As you can see in the figure, we have given one sinusoidal to the input terminal of inverting terminal, and the output is 180 degree out of the phase. Now next, the input terminal labeled with the positive sign is called as the non-inverting terminal. If we connect the input signal to this terminal, then the amplified output signal is in the phase with the input terminal. You can see that in the given figure. Understood? In short, you can say for inverting terminal, the output is 180 degree phase shift, and for non-inverting, the output will be 0 degree phase shift. Got it? Remember this. Okay, one more thing here. The symbol of OPAMP appears like an arrowhead. The arrowhead signifies the signal flow from input to the output. Yes, and this is the basic thing that you can understand from the figure itself. But still, remember this. Okay? So, in the next part of the video, we are going to see the block diagram for an OPAMP. So, let's begin. So, an OPAMP is a multi-stage amplifier. So, we can represent the block diagram of the OPAMP in the 4 stages. It basically has 4 stages, which are input stage, which will have 2 inputs. One is non-inverting and another is inverting. Next stage is a intermediate stage. The third stage is a level shifting stage. And the fourth and the final stage is a output stage. So let's understand how these stages work or plays role in amplification process. So the first stage, which is the input stage. The input stage is a dual input. The 2 inputs are inverting and non-inverting input terminals. This stage provides the most of the voltage gain of an OPAMP and decides the value of input resistance. First stage is known as the dual input balanced output differential amplifier. Next stage is intermediate stage. This is usually another differential amplifier. The input stage drives this stage. This stage is also called as the dual input unbalanced output differential amplifier. The third stage is level shifting stage. Due to the direct coupling used between the first 2 stages, the input of the level shifting stage is amplified signal with some non-zero DC level. Level shifting stage is used to bring the DC level to the 0 volts with respect to ground. There are circuits that can be used in this stage, such as emitter followers using the constant current codes. And the last stage is the output stage. This stage is normally a complementary output stage. It increases the magnitude of the voltage and raises the current supplying capability to the OPAMP. It also ensures that the output resistance of an OPAMP should be low. So these are the 4 stages of an operational amplifier, and from this you can understand how OPAMP works. So please remember these stages. So ultimately you will remember the working of an OPAMP. Now let's move to the another part. Now let's see how the OPAMP looks like as a hardware. The OPAMP IC 741. This IC is the oldest and one of the most popular OPAMP IC. It is a high performance operational amplifier. So on the screen you can see how the OPAMP IC looks like and how many pins it has. Pins are nothing but the terminals. So the OPAMP IC 741 has 8 terminals. You can see one black dot on it. So from that you can understand that the first terminal of the OPAMP. So let's see what are the different terminals of IC 741. The first is offset null. Second is the negative input, which is inverting terminal. Third is the positive input, which is non-inverting terminal. Fourth is minus VEE. It is the negative supply voltage. Fifth is offset null. Sixth is the output of the OPAMP. 7 is a plus VCC, which is the positive supply voltage, and 8 is a no connection pin. So whenever you work with this IC, you will connect the supply voltage to the pin number 4 and 7, and you will connect the inputs to the pin number 2 and 3 according to the input or output need, and you will get the output at the pin number 6. So friends, as I have told already that IC 741 is the oldest one and most popular IC for OPAMP. It is a high performance operational amplifier. It can be used in various analog applications such as integrator, differentiator or summing amplifiers. Along with this, there are so many applications that we have already seen in the previous part of the video. So friend, that was all from my side. I have given you the all important information related to OPAMP. If you have any doubt, you can ask me anytime by following my Instagram page. You can DM me directly or you can comment your doubt. I will surely reply your doubt. So I hope this video was useful. Please share this video to your friends and also help them to learn about operational amplifier. And for such amazing videos, stay connected with Instrumentation Hub and don't forget to like, share and subscribe. Thanks for watching. See you all in the next video. Tata, bye bye.